Okay, so next thing is isomers. So isomers are things that have the same general formula, but that have different structural and different names. So when you see questions like this, they're going to give you a formula, right? So here, for example, we have C6H14. So this is the first question on your alkanes worksheet. And it asks you to draw a structural formula and give names for the 5 possible isomers. So if it tells you that there are only 5 isomers, there are only 5. If you come up with more than 5, you've probably redrawn the same thing and just haven't recognized that you've redrawn the same thing, okay? So first thing we want to do with an isomer is we always want to start by figuring out what family it belongs to. So obviously on this one, we've only done alkanes. It has to belong to the alkane family. But generally how I would go about doing this is I would look over here at my formula, and you're going to find that we have, remember we talked about that CN. So in this case, N is 6. So we look at 14, that falls under that alkane formula because we have 2N. I got a meeting starting soon. Plus, well, there's plus 2, right? Because we have 14. 2 times 6 is 12. Plus 2 more gives us 14. So we know that it's an alkane. So that's telling us that everything is going to have a single bond in it, okay? So first thing we want to start by doing is the simplest structure. So the simplest structure for this is actually just going to be to put everything in a straight chain, right? So if we take our 6 carbons, we put them, excuse me, like that. So that gives us 6 carbons, right? Obviously we need to fill our H's in. So our first carbon is only 1 bond. It gets, well, that's not what I meant to do. It gets 3 H's. This one already has 2 bonds, right? One on the left, one on the right. So it gets 2. Same with this one. And same with this one. And this one as well. Okay, then our last one, it only has 1 bond right now. Excuse me, so 3 H's, okay? So we check it, 1, 2, 3, 4, 5, 6 carbons, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 H's. This matches. So this is our first one, okay? And this, no side chains, 6 carbons in the main chain. So it is going to be hexane. Okay, no prefix, right? Hex for 6, ane because it's all an alkane. So that's our first possibility, everything in a straight chain. Okay, now we have to draw some things that are different. So the only way to do some things that are different are going to be, excuse me, to change how many carbons are in the main chain. So right now we had 6 carbons in the main chain. The way to do this a little differently is let's just put 5 carbons in the main chain. Okay, that then leaves us with 1 more to do some other stuff with. Right, so 1, 2, 3, 4, 5. So where's that 6th one going to go? Well, we're going to make a side chain, right? That's the only way that we can make it different. So we said the other day that we couldn't put side chains on the first one, because if I put a side chain here, technically then it's 1, 2, 3, 4, 5, 6, and it's exactly the same as the first one. I've just bent it. So what we're going to do is we can put it on the second one, right? So we could put it here, right? Obviously it needs its H's. So we're going to give it 3. And then again, we go back to this main chain and we'll fill those things in. Okay, so this needs 3 H's. You know, that kind of shifted some stuff on me a bit. There we go, we'll do that instead. This carbon here already has 1, 2, 3 bonds, so it only needs 1 more H. This one has 2, so it gets 2 H's, right? Remember, always trying to get to a total of 4. So same deal with this one, it gets 2. And this last one gets 3. So now we need to name it. So root-wise, 1, 2, 3, 4, 5 carbons in my main chain. So this is going to be a pent. It's going to be a pentane because everything is a single bond. But in this case, we do have this little side chain hanging out here, right? It's a methyl, and it's a methyl because it has 1 carbon. That 1 carbon is attached to this. So Numbering wise, right, we could either start from the left side or the right side. So if we check the left side, this is carbon 1, this is carbon 2. So I'll put my methyl at number 2. If I started on this side, it goes 1, 2, 3, 4. So because a 2 is less than a 4, we're going to start 1, 2 over here. So name-wise, this is going to be a 2-methyl, right, pentane. So these two are isomers, and they're isomers because they have the same number of C's and the same number of H's, but they're drawn differently and they have a different name. Okay, so we still need to come up with 3 more isomers, right, because we were told that there was 5. So we started by putting the side chain here. If we move the side chain, we can draw something different. So I could move it to here, right? Then that's something different. It looks different and it has a different name. So if we do that, right, we put in, well, I forgot a C, our 5 carbons. Okay, and then, which I'm just going to center this a little more so that when I put that other side chain in, it'll fit. Okay, we're saying that we're going to put it off the middle one, right? So we're going to put that other carbon here so that it's different than that one. Okay, same deal. We add in our H's. Well, that was a really big one, sorry. Okay, this one gets 3 because it only has the 1 bond. Okay, we go back to our main chain and we fill that in, right? So this needs 3. This one needs 2. Shift this around again, sorry. Okay, then this one has 1, 2, 3 things attached to it, so it only needs 1 H. Okay, this one has 1 on the left, 1 on the right, so it gets 2 H's. And this last one gets 3. Okay, so name of this one is kind of similar to this one, right? It's still a methyl pentane. The difference though is 1, 2, 3. It's now on the 3rd carbon, right? If I number from this side, 1, 2, 3. So it doesn't matter which way I number from. This is going to be a 3-methyl pentane. So now we have 3 options. Okay, so 4th option. It's really tempting to be like, okay, well, I started with this at number 2, I moved it to number 3, let's move it over here to number 4. But that's not actually another option. And the reason that's not actually another option is if I move this guy over to here, it's actually a 2-methyl pentane. It's the same thing as this one here that we already drew. Because numbering wise, right, we don't always have to start from the left side. We said we could start from the right side. So if we drew it over here at number 4 instead of at number 2, numbering wise, we wouldn't actually go 1, 2, 3, 4. We'd be going 1, 2. So it would just be that 2-methyl pentane flipped around. So that's not an option. So what that means is I've exhausted all the pentane options. Okay, there are no more because I start repeating ones that I've already done. So that means we're going to have to drop that main chain and down to 4 carbons. Okay, so we're now going to have 1, 2, 3, and 4. So that means I have 2 carbons that I can use to make some side chains. Okay, so either I'm going to do 2 methyls or I'm going to do an ethyl. But here's the problem. If I draw an ethyl, and don't actually draw this, right? If I will pretend that's a straight line. We're going to erase all of this in a second. Say I drew an ethyl in here. Why this doesn't work? Well, my main chain is actually this, right? It's not what's straight across the page, because straight across the page is 4, and going this way is 5. So that means we can't use an ethyl, because this, if you think about it, is really another 3-methyl pentane. We've just bent it in a different spot, but it's the same thing. So we can't do that. That means we're going to have to do 2 individual methyls. So we said they can't go on the first one, they can't go on the last one. So let's try putting 1 on the second one and 1 on the third one. Okay, again, we fill up our H's. So this is going to get 3 of them. This only needs one, right? Because it already has 3 bonds. This one needs 3 because it only had 1. Okay, and keep going, fill them all up. So this gets 1, and then those last 2 are going to get 3. Okay, so naming wise, we look at our root, right? In this case, that root did go right across the page. Okay, so 4 carbons inside of that. So because we have 4 carbons, it's going to be a bute. Everything is a single bond, so it's an ane. Prefix-wise, we've got 2 side chains, right? We've got this one, and we also have this one. Okay, they're both methyls, and they're both methyls because they just have 1 carbon in them. Remember we said if we had 2 of the same thing, we were going to call it a di. So that means this is going to be a dimethyl butane. Okay, we need some numbers to show where they are. So it doesn't really doesn't matter where I start numbering from, right? 1, 2, 1, 2, right? They're both at 2, they're both the same. So this is going to be a 2, 3, right? Comma, because we separate numbers from numbers using commas. Then dash, because we separate numbers from letters using dashes. Dimethyl butane. All right, one more option. So here we put them on separate carbons. The other option would have been to put them on the same, but to put one above and one below, right? So put 4 carbons still in the main chain. But now put 1 up here and 1 down here. Okay, so same thing, fill those H's in, right? This gets 3 because it only had 1 bond. This next carbon doesn't get any because it has 1, 2, 3, 4 already. This one is going to get 3. Same with this one. Okay, going back to that main chain, this already had 2 things attached to it, so it needs 2 hydrogens to get to 4. And this one needs 3. So, naming-wise, similar to the last one, right? It's still a dimethyl butane, bute because 4, dimethyl because it has 2. But now both of these are at carbon number 2. So that means we're going to have a 2, 2. Yes, you need to write the number twice, dash dimethyl butane. Okay, so these are your 5 isomers. They all have the same number of carbons and the same number of hydrogens. You always want to start by putting everything in a straight chain and then start taking pieces off and making side chains. Move those side chains around. When you've exhausted all those options, take 1 more out of the main chain, make another side chain, and move those around. Okay, so that's how your isomers are going to work.